Okay, so we're getting started on reviewing some very specific questions that students asked about from homeworks 13 and 14. So I look at number 4, that's the first one from homework number 13, and I want to discuss some important things. First, I literally copied this rectangle with the average and standard deviation formulas in it out of the textbook, literally the way it is. And I hated that the textbook did not draw the square root symbol all the way down to the bottom, but it must go all the way to the bottom. Everything, the b minus a squared over 12, is inside the radical, not just the numerator. Now, the key to understanding to use that two formulas is this phrase, uniformly distributed. As soon as you see that phrase, uniformly distributed, that means that you want to make sure to use those two formulas. It also means that every probability is the same throughout the interval that it's talking about. In this case, between 13,191 minutes and 13,204 minutes inclusive. So find A and B. Well, A is always the starting point and B is always the ending point. So A is going to be 13,191 and B is going to be 13,204. Okay? So they're the lowest and the smallest numbers. Now, write the distribution. When we say to write the distribution, we want either like it's going to be x tilde u for uniform or x tilde n for normal. In this case, it's uniform. And when it's uniform, you always put A, the lower number, then B, the higher number. So that's just how you set it up. That's the standard format. Finding the mean and the median. The mean just says add them up and divide by 2. So that's what I do here. 13,191 plus 13,204 divided by 2. And that'll give you 13,197.5. All I did on that was follow the formula. Now, as far as the standard deviation goes, I didn't really have room to show work. So I just wrote what the answer was. But the way you're going to do it is you're going to do the B value minus the A value. So it'll be 13,204 minus 13,191. Then you're going to square that. Okay? Then you're going to divide it by 12 because here we are with the standard deviation formula. It says to divide by 12. So I do the highest number, that's what B is, minus the lowest number, that's what A is. Get that difference, square it. Then I divide it by 12, and then I square root that answer because I apologize for the book's lack of clarity, but it's square root everything, okay? And that would give you 3.75 when you're done with that. Okay. Then it says, what's the probability the duration of games is between 13,180 and 13,195? You can't do that because the lowest number is 13,191. So because of this, it's just a typo on my part. I apologize. It should have been 13,191 and 13,195. So we'll have to skip that question. Now, what's the 75th percentile? Now, it's the 75th percentile of the scores. So how many scores are there from 13,191 to 13,204? If you subtract, you'll come up with 13 scores. Then I need 75% of that. So I do 0.75 times that 13. I know it's a sloppy looking 13, but it is 13. That gives you 9.75. I think that's pretty easy to follow. The tricky part comes into play with what do we do with this 9.75? And you have to realize that it is added to the lowest score given, the A value. That lowest score in the entire distribution is 13,191. So then I've got to add 9.75 because that takes me 75% of the way to the last score. And when I add them up, I get 13,200.75. Okay? All right. So now let's go to number 7. And the key phrase here is normally distributed on number 7. Okay? I'm going a little quick because I want to make sure I cover as much as I can in this one video. The final exam scores were normally distributed. The mean is 61, standard deviation is 5. What's the probability that the student scored more than 65? Well, I didn't write this out on number 13 homework, but I did on number 14. This number here is always the lowest number. If you're scoring more than 65, the lowest number is 65. This number is always the highest number. Since the exam, theoretically, it was a statistics class, you don't know what the final score is. If you just put 10 to the 99, that's the highest score possible. the highest number the calculator will calculate. Then it's the mean, which is 65, and the standard deviation, which is 5. So then you just go in your computer and you type in second VARS, normal CDF. You put in your lowest score, in this case is 65. Your highest score, 10 to the 99th power. 61 is the mean, 5 is the standard deviation. And you just hit enter a couple of times, it'll come back with 0.2119. Okay? Big phrase here, normally distributed. As soon as you see normal distributing, that's when you're going to think normal CDF. Okay? Next up, this is telling you it's normally distributed because of the x tilde n. Remember, if it was uniformly distributed, it would be x tilde u. Wants to do the 90th percentile. Since it's normally distributed and you want the 90th percentile, could you use the table to do this? Absolutely you could. Much more difficult, much more confusing. So instead we go with the calculator. But it's not normal CDF. We go second VARS again, but the third choice down is inverse normal curve, inverse norm. Now, what do you put first? You put the percentile as a decimal. So 90th percentile is 0.9. Notice on the next one, it's 35th percentile, and it's 0.35, okay? And then, for both of them are the same, the mean and the standard deviation. So on letter A, you do second VARS inverse norm, 0.90, because you're the 90th percentile. The mean is 75.7, and the standard deviation is 4.8. And you hit enter probably twice or whatever, and it tells you that the score is 81.85. For letter B, second VARS inverse normal curve, inverse norm is abbreviated. What scores at the 35th percentile? 0.35 gives me the 35th percentile. My mean of 75.7, my standard deviation of 4.8, and I hit enter, enter, and I get 73.85. Okay, and those are all the questions from number 13. Now we shoot to number 14, and again, doing very similar questions. I wanted to talk about number 5. I'm only going to do letter A. I'm not going to do letter B. 90th percentile, we're going to do second VARS inverse norm again. You know norm because normal curve right here. That's 0.90 for 90th percentile. 75.9 is the new mean, and 4.4 is the standard deviation. Remember, in the format, for x tilde n, for normal curve, the mean is the first number, the standard deviation is the second number. And I just punch them in. Second VARS inverse norm, normal curve, 0.90, 75.9, 4.4. Those numbers taken from over here, and it tells you 81.54. Now, how do you know how to handle number 6? Well, in all of that paragraph, we hit this really key phrase, normal distributing. So that means norm, as in inverse norm, normal curve, and so on and so forth. It says the average number of hours is 2 hours a day, and it wants to know what's the probability that it's between 1.8 and 2.75 hours. So we know that's the area covered under the normal curve, so second VARS normal CDF, and it always goes lower, upper, mean, standard deviation. Lower, upper, mean, standard deviation. The lower is 1.8, the upper is 2.75, the mean is 2, and the standard deviation is 0.5. And when you do that, it'll tell you 0.5886. So remember, lower, upper, mean, standard deviation. And then we get to the last one I wanted to look at here, number 10. This one has to do with the mean salary. And everything is done with the same with the mean salary, except it's the mean salary of the sample. Of the sample is very important here. The thing that's really important is that you include the square root of n over here. So it's still lower, upper, mean, standard deviation, but you got to divide that by the square root of 10, the sample size, which is 49 plumbers. So 47,300, you want to be greater than that, so that's the lowest number. The upper is 10 to the 99th. The mean is 48,700, and for standard deviation, we're going to use 5,500 divided by the square root of the sample size, which was 49. So divided by the square root of 49. Crunch those numbers, you get 0.9626. So there you go with the homework.